Now, strong acids will undergo complete ionization to give us H plus ions. So if you take, for example, HCl, it's going to dissociate completely. Actually, this should be a complete error, to give H plus N Cl minus. Now, because we know there's 0.5 molar of HCl, so HCl to H plus is 1:1. So 0.5 molar is going to give you 0.5 mole per dm cube of H plus. So if we know the concentration of H plus, which is 0.5, therefore we can find the pH of HCl. So it's going to be minus log of H plus, which is going to be 0.3. So the pH is 0.3. Now, if we do for H2SO4, H2SO4 is going to dissociate to give us 2H plus and SO4 2 minus. Now, here the ratio is 1:2. So if I have 0.15 mole of H2SO4, I will have 0.3 molar of H plus, because this is twice the number of moles. So concentration of H plus here is going to be 0.15 times 2. Here. And therefore the pH of H2SO4 is going to be minus log of H plus, which is going to be 0.5. Now this goes for strong acids where there is complete dissociation. But when weak acids are being considered, a weak acid will only dissociate partially, which means that if you have ethanoic acid in water, let's say I have 100 particles of it, only maybe like 4% is going to dissociate. So you won't have complete dissociation. So there is actually no way that you know how much of the H plus there is. So here for the H plus there's going to be. So we're going to try to use the relationship between concentrations and dissociation constants. So let's take, for example, a general weak acid HA that is dissociating in the presence of water. So if we apply the equilibrium law, so based on this, Kc would be concentration of products divided by concentration of reactants. Now, because this H2O here is a constant, concentration of water can be considered as a constant, we can have Kc multiplied by H2O. So Kc is a constant, H2O concentration is a constant, and these two, they're going to form a new constant which is called Ka, which is the acid dissociation constant. So we have multiplied this, so we end up with Ka to be equal to 3O plus, which is actually H plus, A minus, and H. So for any weak acid, Ka will be equal to the concentration of H plus multiplied by the concentration of the conjugate base and the concentration of the acid. Now for a weak acid, which is monoprotic, it will give you H plus and A minus concentration to be the same. The ratio will be 1:1. But if you have a diprotic, then the ratio will be different. You'll have to consider this. But in this case, A minus and H plus will have the same concentration. Therefore, we can have a new expression where Ka is equal to H plus to the square over Ha. Right? And therefore, you can easily calculate H plus by doing the square root, and from this you can find pH. Let us see a first example. So you have ethanoic acid concentration which is given, and you're given the value of Ka. So we can write that Ka is concentration of H plus and then the conjugate base over concentration of the acid. Now, because it is a weak acid and because it's going to dissociate in equal ratio, H plus and CH3CO minus will have the same concentration. So Ka will be equal to H plus to the square divided by concentration of the weak acid. And from this, H plus can be calculated. From this, we can calculate the pH value, which is going to be negative log of H plus concentration. So you get the pH to be 2.88. Now you will try to work the question number 2 and the question number 3. And if you do this correctly, you should get the answer here to be 2.7. And here you should get the Ka value to be this.